listen. So my name is NURLIYANA binti GHAZALI, and today I'm representing for you about our topic, which is introduction of transformer. First of all, we're going to the definitions of the transformer itself, which is a transformer is an electrical device that transfer electrical energy between two or more circuits through electromagnetic induction. So first, what is the meaning of the transformer? Is a static device. The definition of the static device is a device that converts one type of energy without physical movement, which is when we look at the transformer, we can easily change the locations. So the word transformer comes from the word transforms. The transformer is not an energy conversion device, but it is a device that can change the electrical power at another voltage level through the action of the magnetic field, but with a proportional increase or decrease in the circuit ratings without a change in frequency. So basically, a transformer is about the changing of voltage with the help of electromagnetic. So transformers can be two types, which is either can be step down or step up. If we use the transformer for step up, so the voltage will be increased, and if we use the transformer for the step down, so the voltage will be decreased. Thank you.
Good morning to my lecturer, Dr. Kanisan. First of all, my name is ISMAIL, and I will present you about the theory and law of transformer, which is the Faraday's law of electromagnetic induction. Okay, first we know that the working principle of transformer is depends on the Faraday's law of electromagnetic induction, which is, we know that Faraday's law stated that the rate of change of flux linkage with respect to time is directly proportional to the induced EMF in a conductor or a coil. And then we know that the Faraday's law is being introduced by the Michael Faraday, which is the English physicist, in 1831. He said that when the change of the magnetic field, area of the loop, and also the angle of the rotation can affect the change in the magnetic flux. And then because of the change in magnetic flux, when we follow the Faraday's law, we can see there is a change in the induced EMF. Okay, so now I will explain a little bit about the working, how the transformer is work. And then this is the same example of the application of the transformer, which we can see that we provide some supply voltage to the primary coil, and then there is a current flows through it, and then it will make a change of current, and then it also make the change in the magnetic field, which is it will induce the alternating voltage into the secondary coil, and also induce the alternating current in the circuit of the secondary coil, so that it happen the induced current in the transformer. Okay, okay, that's all from.
Okay, hi, Assalamualaikum. My name is HAKEIM AMIR. I'm from 3SSCF. Okay, first of all, today I would like to present about the self-induction and mutual induction in transformer. And at the end of the presentation, I also would like to present about the basic operation of the transformer. So, by the definition, the self-inductance is the induction of a voltage in a current carrying wire when the current in the wire is changing, and the magnetic field created by a changing current in the circuit itself induce a voltage in the same circuit. So the definition of the mutual inductance also the phenomenon in which a change of current in one coil causes an induced EMF in another coil placed near to the first coil. So if you see the diagram that I have drawn before, for self-inductance, when we supply an AC current, the coil will produce a magnetic flux. So the equation that we get is the self-inductance is equal to EMF is time with negative L, and time with the rate of change of current. So if you notice that we have the negative signs for this equation. This is due to the last law, which is when the same magnitude but the different polarity of the supply voltage. That's why we put a negative sign. So for mutual inductance, when the current is passed through the first coil, and it will produce a EMF that will causes to the second coil. So from this phenomenon, we can get the equation, which is EMF2 is equal to M21 is time with the rate of change of current in coil 1. So it's same to the EMF1, which is equal to M12 is time with the rate of change in current 2. And the magnitude of the flux is directly proportional to the magnitude of the current. So this phenomenon is basically related to the Faraday's law, which is the EMF is directly proportional to the rate of change of flux leakage. So okay, we back to the basic operation for the transformer, which is basically the transformer is for to step down or step up the current. So this is given by the equation, which is VP, which is primary coil, divided by NP, which is the number of turn of coil, is equal to the VS over NS, which is the secondary part. So if the NS is greater than NP, it was the step up transformer. But for NP is greater than NS, it will produce the VP is greater than VS, so it was the step down transformer. So since the high voltage carry in the wire are significant greater than what is need in home, so transformer are also used extensively in electronic product to decrease, which is the step down transformer, to supply voltage to a level suitable for the low voltage circuit. So for transformer also we need to increase the voltage, which is we use the step up transformer before transmitting the electrical energy over long distance through wire. Wire here have a self resistance, so which lost energy through joule heating at rate corresponding of the current. By transforming power to a high voltage transformer, enable economical transmission of power and distribution. So I think that's why the transformer is needed to our industry and for ourselves. Okay, thank you for me.
Good morning everyone, I'm Ting from Group 4. So today I'm going to discuss about the questions based on the application they have chosen by our group, which is transformer. We all know that transformer is always connected to an AC supply. So now here's the questions. Can a DC current be applied to a transformer? So the answer is no. This is because transformer works on the Faraday's law of electromagnetic induction. What did the Faraday's law state? Faraday's law states that when there's a change in magnetic flux, there will be an induced EMF. So, if the primary coil of transformer is connected to a DC supply, the flux produced will be constant, so there will be no induced EMF produced. Okay, we can see from this equation, I equals to V1 minus E1 over Z1, where V1 stands for the voltage supplies, and E1 stands for the induced EMF in primary coil, and Z1 stands for the impedance from primary winding. So when the primary coil is connected to DC supply, there will be no induced EMF. So E1 will equals to 0 and Z1 will be equals to R1, where R1 is resistance of primary winding. And the reactance of primary winding is 0 when it's connected to a DC supply. So the value of primary current is I1 equals to V1 over R1. And the magnitude of this current will be very high because E1 equals to 0 and the R1 is very small. So transformer can damage due to this high current. That's all. Thank you.
Based on the question, we know that the value given is the value for primary voltage, which is VP, that is 120 volts, and secondary voltage 5 volt, IS 700 milliampere, and NS 30 turns. So we can know that this is a step-down transformer. Why?
Hi, so today I will explain the conclusion of the transformer. So the first one is V output, which is here, across the secondary coil depends on the ratio NS over MP with respect to the V input, which is here, V input. Okay, NS is the number of the coil in the secondary, which is here, and NP is the number of coil in primer, which is here. Okay, so next is the power of the primary is equal to secondary, and there is a loss of power between input and output coil of the transformer. So that means that there is power loss between output and input. So that's all from me. Thank you.